I'm Ye Wong from Eco. We are actually dealing with water. We have another company, System Vacuum. We represent raw vacuum storage technology. At the same time, we also actually dealing with wastewater treatment. Our booth is at the Hall 6, your EU Pavilion. Both this technology we are dealing, especially the EcoClean technology, is a licensee technology for CDS, which today is one of the most, I would say, world leader in water filtration, using the water as an energy, and it is non-blocking and the self-cleansing. Thank you. Okay. Just continue while the slide is on. I also actually act as a council member with ECOM. In fact, ECOM to this year also have a booth sharing with us. ECOM stands for Association of Environmental Consultants and Companies, and we will actually anytime open the memberships to public. Our movement is more or less an NGO, but it's more of a definitely not political, but it's more pro-environmental. We aim to help in our, our late 50s, 60s to contribute what we have learned in terms of experience back to our society here. Actually, to start off, I need to introduce, before the CDS technology, what is gross pollutant trap. Basically, CDS technology is, is derived from actually the requirement of a gross pollutant trap. A lot of people, I think, may not be aware of gross pollutants means, you can see from here that there's a CDS unit here. Without this trap, you'll find all the lake with full of rubbish. So if you open the lid and you lift up the basket, you'll see there were a lot of rubbish that have been trapped. Okay, first you must know how do we make this work. Gross pollutant trap, basically they are in the urban stormwater to really treat the water so that the water is not so contaminated. You need actually to involve what they call the treatment train concept. And among the treatment train concept, I think you're all aware, the most important step is requirement is actually a GPT. It's a short form for gross pollutant trap. So you will look at the rubbish in the urban stormwater. Generally, you find three kinds of rubbish. You have the floating one, you have the the neutral buoyancy, and you also have the sediment of fine or coarse. And you generally the percentage is in the stormwater. Most of them are either they are settling or floating above, and you need the kind of actually special design to trap really all this into the stormwater. This is it has a different characteristic during the time of suspension or during the time of storm. So generally, it's been recognized that internationally that this treatment train will consist of 5 steps, starting from the prevention, educations, and then finally, of course, the secondary end. Today, we are actually talking about not only treating it, but trying to close the loop by using the water, but by reuse the water, actually. So prevention has its limitation because not everybody listen to you. And then, of course, source control is also another problem because as the labor costs get higher, you need to spend more money. And then for the primary treatment, eventually this GPT found actually to be more suitable in the sense that it is much more cost effective, but with a bit of cost, higher capital cost. And then that is only a physical treatment. So you really need some kind of further treatment called secondary treatment, which is actually to remove the nutrient. Of course, generally, like in Australia or other countries where they have a vast piece of land, so you can afford actually to put in a wetland or grease. Actually, the biggest wetland in the world is actually our Putrajaya wetland. This is an artificial wetland. So it actually serves the purpose of secondary treatment. Okay, and reuse. In fact, the biggest project for stormwater reuse, I think you know, is the Singapore River, where they close the barrage and they reuse the water. So, but of course, even we find generally that if you just do without the reuse, you actually, it's not sustainable because there is no value coming from the end of the treatment, and you are just depending on government budget or what sort of one way of subsidy to make the water clean. So we are actually advocating the next movement should be closing the loop and reuse the water that we treat, even from our stormwater. I'll show you some example later on from here. Okay, so looking at this treatment train, if you are short of money, you have or you want to take the steps, right? Basically, you have to take every step, but we emphasize that the step 3, which is the primary treatment, which is the most effective, should be considered first. So, okay, this is not actually a new idea. I mean, it has been involved since the 90s. You see, how it works is basically they function by floating traps, log booms. Start from the agriculture side. I think they even use bamboo and stay on. You go to China, they still use bamboo to trap the floating rubbish. Overflow device is more for oil and grease interceptor, and then the direct screening comes in with just a net across and trying to catch whatever you can within the size of the net. And vortex separation later come in using water vortex. And eventually there was a breakthrough of this new technology called CDS. It stands for continuous deflective separations. Of course, with the R&D, CDS is not, it is a patented technology. That is the pity. Okay, some of the example is for floating traps, the lock booms, right? And then this is what I call the overflow or underflow device, good for oil removal generally, and sediment trap as well. And the third one, of course, is most of, which is now commonly used, which is direct screen. And recently there's a number of proprietary systems. They also involve around this technology and have actually improved the efficiency. Generally, the direct screen efficiency is about 30% now. Vortex separations is very good because it's very good for sediment removal. But somehow when you have floating rubbish, the floating rubbish tends to be spin away rather than, so it is actually good for sediment trap, but definitely not a standalone technology for floating rubbish. So, but of course you can actually do a bit of raw jack at having a combination of technology to compete with us, because we generally find that CDS technology is all in one. That means we trap oil in grease, we trap floating rubbish, we also trap all the sediment to very fine. With the finer screen, as low as 100 microns of particles can be removed actually using the technology. So, and of course, this is just give you an overview. So this is actually the latest technology from the 90s. We also call ourselves the third generation. It is a non-blocking technology. If you see from here, the water is actually cleansing the screen all the time because it's floating tangential. The screen actually causes the negative pressure to be formed at the back, and it causes the water to do a U-turn. So eventually all the water is actually returned back to the downstream. You see from here, pollution runoff. Here there's actually no energy to drive the system. The energy is provided by having a wheel across the drain that will convert the potential energy to kinetic energy to drive your vortex, and then in contact with the screen, cause it to deflect through the oil detention buffer. Is actually go further down, and that process actually removes the suspended particles. Whatever's heavier, the intensity of water will settle, lighter the water will stay afloat. But using a basket at the bottom, when you lift it up, the basket overstretches a little bit. Technically, you remove 100% of all the captured materials inside the CDS. Construction is very easy in a sense that everything is actually done. Just give me 1 minute. Everything is done in a factory. It's off-site. If it's a renovation, so we just cut the drain, put in the diversion chamber, retrofit this piece of, this set of precast component, and then that open up the weir. That CDS, in fact, it's a machine. It is actually then in action. We have past experience doing CDS installation, like in urban area. For a small size, it's just give us an overnight. In fact, we can do it overnight. We can do it a couple of days for a bigger unit, or a couple of weeks for a much bigger unit. So it's all depending on the size and so on. You help me, okay. So I show you this project. This project actually has been carried out for more than 15 years, and we continue to maintain it. If you look at the water quality, if you don't look at Semuanya, Malaysia, you will think this is part of UK actually. Okay, next. So back to the CDS technology. Okay, I have this. Okay, there's a plan you can see, and this is actually the cross section. You don't see much actually exposed on the. Sorry, you don't see much actually stick up on the air. It's flush with the ground. If you look at how we treat the water, you don't have to design to treat 100 years. All you need to do is to design to treat about 3 months event, which is actually equal to 95% of the water. The stormwater, the total water that falls onto the ground. So when you talk about the flow, we generally talk about the volumetric flows for CDS. So if you look at how this technology compared to our conventional direct screen technology, you can see from here straight away that this is more or less 3 times more effective. Because generally the performance of all this non-direct screen, it gives only about 25 to 30% efficiency compared to the CDS line, which is continuous right on the top at about 100%. Okay, these are independent reports with certified CDS is having it's still the highest, most effective means or technology into the market. So maintenance cost is generally also considered. And because it's offline, so even the EDA don't maintain it, it still will not cause actually flooding because it's not in the waterway. So cleaning is actually by basket. I will just quickly show you how cleaning. All you actually need is actually a lorry crane, or a lorry plus crane, or a grab. In Malaysia, in some small CDS, we actually just use labor force with a few scaffolding and a wheelbarrow, put into a van, and we walk there and hoist it up. So you think there's not a lot of rubbish, but then when you lift it up, you see there's a amount of rubbish, which you can imagine. If you don't do anything to your drain, all this will eventually end in your river or your sea. So over the long run, your whole environment will be polluted. So anyway, this was just a demonstration showing the cleaning, and I think more for the students to do research. That's why there is a small tray. You'll be surprised. You find even the drug syringes inside there. So imagine if these drug syringes get downstream and somebody had an AIDS or whatever, you're playing with the water. It can be very dangerous. Yeah. Okay, so we have a range of CDS. So some small CDS, like we use it for rainwater harvesting, you just actually use one hand, would be enough to lift up the basket. So you can also bring in the vacuum suction to suck it out by vacuum, or using this grab if it's just the vegetation and so on. And then of course, when you select the GPT, generally you look at this kind of parameters. Most of the government found that if you look at the life cycle cost or cost benefit analysis, you find CDS is still ranked number 1. Okay, there are number of awards on this technology and been recognized now worldwide. In fact, there are actually more licensee in the United States than where the country first evolved with this technology, which is Australia. And we are actually the 3rd country who used this technology. After that, it was, I think, the Korea, the Europe, and of course, direct investment by CDS in the US give a lot of impact on promoting this technology. We have actually done several projects in the Mitini, Iskandar region. This is actually a half finished. I just want to show you, you just follow the video, you see the water gets in, you will get into what we call the CDS unit, where everything is actually mixed up. Yep, you can see the floating stays and everything is suspended within the time you settle down. And now you look at actually the water comes out. Yep. Actually, when we are doing it, we are throwing more rubbish into the systems, at the same time. But of course, you can't see from there. So this is another angle shooting to show the water comes out. Actually, is we generally have about 80% of suspended solids removal. That's why you see the color of the water changes. Next. Okay, this is another one. This is actually happening in Dampoy, where people throw all kind of rubbish. Squatters are there, illegal workshops, oil increase, everything pour into the longgang, You can see the other side, when it comes through the CDS, it come out, the oil, suspended solids, and almost everything are been removed. So when this water flow further down, imagine that you have a little wetland and all that, you actually more or less revives your water, and there's actually no reason you cannot harvest the water and reuse it, Okay, this actually shows you, this whole thing is not driven by any electrical energy. The water, because we are converting the potential energy to kinetic effects, that actually drives after the water being filtered and free of rubbish, it can actually produce, you still carry on with actually energy. So when I write about this paper, we are now having about 2 pilot projects where we take on from the CDS technology and we are going into an area of what we call non-electrical power-driven filtrations. We treat sewage, we treat industrial waste, and of course we also actually cleanse treat, say, the very dirty water from class 4 or 5 to class 3 for the moment without any electricity. Okay, so I just quickly jump. This has been specified in the MASMA. I think there's a reason that MASMA comes out. This been targeted for MASMA. In fact, it actually over complies the requirement. It is the cheapest. I think better than a lot of technology. I just quit this. Okay, the second generations, the trash screens, the direct screen, sometimes it's also a factor of flash floods. That's why I say in fact, the government actually should consider to use more of this our CDS rather than still continue with the trash screen. So these are actually some of the flooding issues, which if you have an effective CDS, you won't get that kind of downstream blocked up by rubbish. Some of the projects that we've done, I think, just quickly overview. In Malaysia, these are project Malaysia. Mitini, yes, we have a lot of work in Iskandar now. We actually do this project in a very short time at half the price of any conventional, of the conventional trash screen technology. We are involved in the river of lives. Okay, and this is the area that we actually have moved ourselves a bit beyond. We actually managed to participate in the first green building project developed by Shell to achieve what they call the Gold Green Building Index. What is required, because it's actually the ability of CDS to remove 80% of suspended solids plus 30% of phosphorus and some degree of nitrate removal. So this is actually the, and in fact, it doesn't cost the developer a lot of money, just maybe a couple of $100,000, they can achieve 3 or 4 points, you know. So when the second green building projects, SPCD approached us through their consultant, and of course they were thinking of actually harvesting the water from the rooftop and then bring it down, and then I said, well, why don't we do it something even something bolder? Why don't we treat the water from the stormwater itself and reuse it for irrigations? I think they took the advice. So it's been now constructed and used for irrigation for the first tower. And of course, the future tower, they will straight away use a CDS unit. So this, we also have actually used the technology incorporating into the first flask and the final screen for rainwater harvesting, where we not only we treat it, we also actually store it. We also now move in the downstream. That's why my principal from Australia is here. These are what they call the modules. They are made from recycled plastics, and you wrap it around with a HDPE liner, and that effectively acts as a good storage. And it's cheap, it's environmental friendly, because you have a usage for your recycled plastics. So this is actually the design of a CDS filtration units. We make it out of fiberglass, all made in Malaysia. And we also have done it for bungalows, which is all self-activated. We have built 2 universities out of this, using this for universities. And okay, this is the interesting thing. I leave it at the last. I hope I can finish in the next couple of minutes. Right? We actually treat the water quality from very dirty water to class 2 without any electricity. The flow chart in this process is we actually use an environmental friendly flocculations technology, which is extract from a timber species, which is a waste product. You dose it into the CDS unit, and when it comes out, you can see the color of the water here, right? Almost, I would say, starting from the color of teh tarik, the color of the green tea, and when it comes out, actually, it shows the color of the mineral water. So that, we tested the water actually. It is actually better than class A. Is close to actually nearly 2B. Okay. So, but of course, that earlier plant, we actually do it together with the water supply company, because it actually, the flocculation actually removes the nutrient, so you get clean water. But on the other hand, the nutrient into the flocculants, you can actually harvest it and reuse it as a fertilizer. So you not only reuse the water, you actually also remove the nutrient and use it as a fertilizer. But of course, the nutrient, because you don't have the technology to extract it, so we buy from Singapore. Actually, Singapore buy from Brazil, and we know it's a tropical forest product, but there's no choice. It costs about 2 cents actually to produce a ton of water. So we go one more steps actually now is also using CDS technology for the filtrations. This is actually a plant set up in our office on top of our existing sewage treatment plant. If you look at the color there, it's actually shit water, you know. It's definitely smelly and pungent. Totally, of course, if it's a real situation in the drain, it will be no electricity. So here, of course, we have to pump out water we have to pump out sewage from the sewage treatment plant and let it gravity flow down through this, I call it the reactor bed. We have microfilm, and we also have this, like just now the Czech Republic, we import from those minerals where there's a cation exchange and electrical charges taking place. And then after that, the last one, we actually use a sand bed. So, and with a bit of, with the end with this hypochlorite treatment using chlorine, we actually achieve the result. You see the color of the other side. The quality of water is even better than generally your class A. In fact, this is the result of the water, of the sewage water. So in other words, we can actually say use this technology for the long houses where they don't have electricity or kampong, or either for drinking water or the sewage water. So totally without electrical power, we can actually now have a technology to treat the water. At least if you don't reuse, of course you don't reuse sewage water, but if you reuse the water, it actually can be, for all purpose. Okay, and of course now we're also promoting this idea of separating the sewage, actually during the flow, the infiltrations of water, so that the sewage will not enter into the river. So this is what we call the CSO, Combined Sewer Overflow Device. These are some of the slides. The last one is now we are cooperating with the Indian government research company. We develop a hybrid using CDS, and then beyond that, we actually use a nano metaphorous, I would say quite a high tech with activated carbon, and that is actually very, very compact. We have actually submitted a tender, like we are actually able to treat 150,000 PE and fit into a land site of less than 1 hectare, which generally using any conventional technology, you will need a space of 5 times this size. So finally, I did just on time, I finished my